Good day, this is Jim Pytel from Columbia Gorge Community College Renewable Energy Technology Program. This is EET 121, Digital 1. Today we're going to discuss using Karnaugh maps and POS expressions. By now you should be pretty well versed in using the Karnaugh maps and the SOP expressions. POS expressions, exact same thing, except you're mapping ones. Okay, so I'll go ahead and give you a binary expression, a Boolean expression, and we're going to go ahead and figure out how to map it using a POS expression and the Karnaugh maps. So here's this expression right here, and here is a blank Karnaugh map. It is in the standard POS means of expressing it. Basically, all variables are in the domain are inside each sum. So our domain is A, B, C, and look inside each sum. You've got an A, you got a B, and a C term. So again, what we're trying to do here is map our zeros. What are the binary values of the sums that will give us zeros? So in this case, if A was a 0 and B was a 1 and C was a 0, because remember, a not 1 is a 0, this first sum term here would Boolean add up to a 0. So we're going to go ahead and map 0, 1, 0 on our Karnaugh map. So 0, 1, 0 and place a 0 right there. Okay. Next guy, 0, 1, 1 would give us a 0. So let's go find that 0, 1, 1 right next door. This guy, 1, 1, 0. So here he is right there. This one, 1, 0, 0. There he is right there. So how are we going to group these guys? Let's go ahead and do this one in blue like that. And again, it's 2, 4, 8, 16. Well, in this one, it's a 3 variable, so you can only go up to 8. And this guy right here. Okay, so how do we write what that expression is? So blue here, it looks like A has to be 0. So A. B has to be a not B because that's a 1. But C could take either 1 or 0. So, and remember, that's a sum term. And then we're going to do, because remember, it's product, oh geez, I'm sorry. Just destroyed that. It's products of sums. Here's our product term, here's our sum. Our next sum is actually going to be in red, so let me switch pencils. This guy here, what is this? Well, it looks like A has to be a 1, so it's going to be not A, or, and in this case, B can be either 1 or 0, so he doesn't matter. C, because C has to be 0. Okay, so our resulting expression should be A or not B and not A or C equals our output X. Okay, one thing I want to draw your attention to, it looks like related problem 4-31 actually has an incorrect answer. The correct answer that you should be getting is X or not Y, ANDed with X or not Z. For some reason, they have another term in here, not X or Y or Z, but that you don't need that. I don't know why they put that in there. So if you get this answer here, you should be tracking. Okay, let's try a 4 variable product of sum expression and try to Karnaugh map that and come up with a minimum expression. So let's try this one right here. And there you go. Looks like we've got 4 sum terms here, but look at this 4th term here. This 4th term is missing our C variable. So basically it is not a standard POS expression. We need to expand this. How are we going to expand this 4th term? Well, it's not A or B. And since C doesn't matter, it's going to be C and not C. Okay, so we've just expanded that 4th term to these 2 right here. So now what are the binary combinations that are going to give us zeros here? 0, 1, 0, 0. We're going to map that one, 0, 1, 0, 0. Put our 0 there. 0, 1, 1, 0. Going to map that. and there he is right there. 0, 0, 0, 0. There you go. Now this guy, skip that fourth term, and we got to go to our expanded two versions of the fourth term. So it's 1, 1, 0, 0, and it's 1, 1, 1, 0. So 1, 1, 0, 0 right there. 1, 1, 1, 0. Where is that? There you go, right there. Totally correct, right? Wrong. Fooled you, because check this out. We forgot this not D right here. So that not D should be 0, 1, 0, 1 is going to give our 0, 1. So this guy needs to be replaced with that. Okay, so now what is our combinations? How can we group these things? Remember that these diagonal ones are not adjacent, so we really can't group those. But we can group this guy. And because wraparound adjacency, we can group this guy. These right here, can't do much about. Okay, so what is, I'm going to go ahead and let's do just this term, just that term. Those are easy because it's A or B or C or D. 0, 0,